Hey, what's up everyone? Jason Turley here, back with another video going over everyone's favorite beginner-friendly capture the flag resource, pwntools, or rather pwngym, which hosts their practice challenges when there's not a live competition going. So we're going to be looking at the forensics category underneath the pwntools 2024 event that wrapped up a couple months ago. Now, forensics isn't something we typically look at on this channel, so I figured it'd be good to kind of showcase some of the tools and methodology that you'd use to solve these challenges as well. And it's a nice mix up, it's a nice breath of fresh air from like binary exploitation and reverse engineering and pen testing kind of challenges that we normally see on this channel. So if I open up the first challenge, scan surprise, we see the description says, I've gotten bored of handing out flags as text. Wouldn't it be cool if they were an image instead? And then you can download the challenge files here. You can also launch an instance as well. And so let me just right click and copy this link. And then if we really wanted, we could peek at some of these hints just to get an understanding of what's going on. There's really no shame at looking at hints, especially when you're first getting started, or if the challenge really is just that confusing, or perhaps it's not worded very nicely. So QR codes are a way of encoding data. While there's most known for storing URLs, they can store other things too. Interesting. So mobile phones have included native QR code scanners in their cameras since version 8, or Oreo for Android, and iOS 11. Android phones, they always like to have some type of cool code name for their operating system. In this case, it was Oreo for version 8. Looking over at the third and final hints, if you don't have access to a phone, perhaps you're in school or some type of area where you don't have access to a phone, but you still want to do these challenges, you can use pwntools, and we'll look at that tool suite in a second to convert an image to text. So with all that reading out the way, let's have some fun. Let's rock and roll. Let's open up a terminal, enter in our tmux session, and let's navigate to where we store our pwntools challenges. We need to make a new folder. I'll just call this one, what was this challenge? Scan surprise. Scan surprise, hit enter, cd into that directory, and now let's download our file. We can see that it is a zip file, so we can unzip it. Pretty straightforward. And we see that it creates a few subfolders: home, CTF player, drop-in, and we see a single file called flag.png. Let's hit CD and then tab complete just to make sure we get to the correct directory. So we see one file, flag.png. If I don't trust it, I can run the file command on it, and all this does is tell us what kind of file it is. PNG image data, 99 by 99, so the size, and it has a 1-bit color map. It's not interlaced, whatever that means. So if you're ever curious how the file command works and how it's actually dictating and denoting what kind of file this is, it's not the file extension .png. That's something that only Windows cares about. Just for the sake of argument, if I copy flag.png to flag.txt and I run the file command on it like this, it'll still tell us that it's a PNG image. Now, how does it know that? So files have something called a header, or like magic bits in the beginning. So if I do a command like xxd, which lets us view hex of a file on flag.txt, and I only really care about the beginning, so I'm gonna pipe that into head, we can see these magic bits at the beginning, 89, 50, 4E, 47, and that's going to correlate to a .png file. If you really wanted to know more, you could always just Google magic file header, something like that, and we can see the list of file signatures on Wikipedia. If I do a Control F for PNG, hit enter a few times, we can see right here the sequence of bits that correlate to a PNG file. So just a little trivia, just a little knowledge. That's how computers actually determine what kind of file this is. It's not necessarily the file extension. That's kind of irrelevant. It's actually the magic bits in the beginning. So I don't need 2 copies of the same file, right? If we do like a diff on these 2 things, flag.txt and flag.png, they're the exact same. I don't need them both, so I'm just going to remove the text file that I created. So we're only working with the PNG that we downloaded originally. So we can open this up and we can navigate to like the open folder and just like click and be all slow, go to YouTube, go to pwntools. Where is it at? Scan surprise, home, and then open this up and we see it's a QR code. So that's pretty slow, and we like to use the command line over here. So instead of using the file explorer, if you're like a Windows user on Linux, you can use a command called EOG, Eye of GNOME. And if we really wanted, we can see if there's like a manual page for that. Yeah, the GNOME image viewer. So you just specify Eye of GNOME and then some type of file, and it will open it up. It might not be installed by default, so you could just, sudo apt install it, sudo apt-get install, or whatever package manager you're using. So let's come back here. So it's a QR code. So at this point, it's nothing really special. It's nothing fancy. You can just scan this with your phone. But like we saw earlier, you might not have access to a phone. Maybe you're in some type of environment where you just don't have it, or you're in school and you don't want to get in trouble by pulling out your phone. So you can do it from the command line, and we did see the hint said we could use something called pwntools. So if you Google and kind of search for pwntools Linux, something like that, you will get a couple hits, you will get some results, and you will get this page that talks about how ZBar is an open source software suite for reading barcodes from various sources, such as video streams, image files, and raw sensors. So there's an about page, and there's some downloads, and we can download the source tarball, or they have these different links for Linux binaries. If we try to click here, we do get an error. I don't think Debian 6 is the current version. And if we click on this, we can download it here from sourceforge.net. But as far as I can understand, as far as I can tell, this project really isn't supported anymore. So we do get a ZBar tool, or this zip file, or this bzip file rather. And if I just go to downloads, ZBar, move that to temp, cd, into temp. Okay, so it's bzip to compress data. If we wanted, we can bunzip it, bunzip to it, or you can just use tar, tac x for extract, J to specify this is a bzipped to file, and then F for the actual tarball. So ZBar. And that will work. We see that we do get an output directory, and we can go in there and we can start opening our files. We see that there's a README. We see that there's news and install. So if we peek at the install, it tells us to run the configure shell script that comes here in different steps. So configure and then make. Oops. So if we try doing this /configure, /configure, it will give it a shot. It will give it its best effort. We can see that it's checking all these header files. It's checking the compiler. And we do get an error. Test for video support failed. Try running it again with tac disable video to skip building video support. So let's try that. Configure. And let's paste in disable video. Okay, seems like it's making a bit more progress this time. But no, we do get another error. Unable to find image magic, which is a package, it's a tool, greater than 6.2.6. Okay, so it is getting a little bit annoying. It's getting a bit tedious. A better way to do this is just directly from the package manager, sudo apt, and then just ZBar tools. Enter my super secret password. Apt install ZBar tools. And I already have it installed when I solved this challenge earlier. But that's how you would do it. That will save you a lot of time. You don't need to navigate to like these outdated zbar and these outdated SourceForge repositories. When we did see earlier, there was a GitHub repo, so we could go there, but we do see that the GitHub repo is a bit old. Well, maybe not. The last commit was 4 months ago. There are different releases, and this is to support that last website we saw that stopped being developed and supported in 2012. So just giving you a few options here. I believe the package manager is the quickest and most sane way. Just sudo apt install zbar pwntools, or if you're on some type of Arch system, you could just pacman install it. Okay, so let's get out of here. Let's actually go back to our challenge directory. Okay, ls-l. We need to go into our home folder. There we go. We have our flag. And if I do zbar like this and just hit tab, not once, but twice, we see two different commands come up, zbar cam and zbar image. If we wanted, we can look at both of them. What is zbar cam? If I print out the help, scan and decode barcodes from a video stream. Okay, we don't really have a video stream to work with, but we do have an image. So what is zbar image? Scan and decode barcodes from one or more image files. And there's like a list of like help, but let's try just running zbar image and then the actual image file. I don't think we need verbose information or anything like that. Run that on flag. And there we go. We get the QR code. Make sure everyone can read that. QR code, pwntools, peekaboo. So that's pretty nifty. That's pretty neat. So you can create and make and like read QR codes from the command line. So I already solved that one. So let's move on to verify. Let's see what this one's all about. People keep trying to trick my players with imitation flags. I want to make sure they get the real thing. I'm going to provide the SHA-256 hash and a decrypt script to help you know that my flags are legit. You can download the flags here, or the challenge files here. So like always, let's just right click and copy the link. We can open up this instance and maybe that'll give us a little bit more details. So if we look at these hints, if we really cared, we could say checksums let you tell if a file is complete and from the original distribution. If the hash doesn't match, it's a different file. Okay, so hashes, checksums, when you're downloading or transferring files, sometimes it's nice just to confirm that the file hasn't changed when it was being transmitted, and just hashing it is a good way to do that. Let's make this small. Let's make a new directory called verify, cd into it. Let's download this challenge file, unzip it. Okay, that made a lot of stuff. I'm not going to count all of that. We see it made a lot of files with this random text. And then at the very bottom, we see something called checksum.txt and decrypt.sh, some type of shell script. Okay, let's, we can remove the challenge.zip since we no longer need it. And I can just hit tab complete to actually navigate inside these files. So what is checksum? Okay, maybe this is our actual checksum. What's in these files? LS files? Oh, okay, that's a lot. That's a lot of random files. Let's run the file command on everything inside of here. They're all ASCII text. Okay, can I cat out? Cat them out? Head? Or a tail, I guess, doesn't matter. There's just a bunch of random data. Random data. Okay, I'm curious if we need to see if our checksum is in any of these files, because we do see they do have the same length. But before we do that, let's actually take a peek at this decrypt.sh script. We see it's written in bash. So check if the user provided a file name as an argument. So there's an if statement and this little $, pound symbol, $, hashtag, whatever you want to call it. All it's saying, it's a shorthand, it's a syntax in bash for checking the number of arguments. So if the number of arguments is 0, then print out this message, which just tells us how to use the script, decrypt.sh, and then some type of file name as an argument, and then exit. The next comment states, store the provided file name in a variable. So whatever file name that we specify here in this placeholder, it's just saving it into a variable that's appropriately named file name. And then on line 13, we see the comment, check if the provided argument is a file and not a folder. So yeah, just make sure we actually give it a file and not a directory or a folder or anything like that. So this tag F in bash does exactly that. It's making sure it's a file. So if it's not a file, print out an error. And that's it for the checks. The next big thing is if there's an error reading the file, print an error message, and then we see this call to open SSL, encrypt, tech D. Interesting. We see these different algorithms, these different ciphers being ran, AES 256 with cipher block chaining, and PBK DF2. I'm guessing iter means number of iterations, so 100,000 iterations. Provide as salt, and then the inputs is whatever file name we give it, and then the rest is cut off a little bit. Let me zoom out. So if TAC K, pwntools. So what is that? Let's look at the man page for OpenSSL so we can get a little bit more context about what's going on. OpenSSL, it's a cryptographic toolkit implementing the secure sockets layer and the transport layer security, protocols and related cryptography standards required by them. Okay, and we see all the different things that OpenSSL can be used for: public key encryption, SSL, certificates. Maybe this is what we want, the encryption and decryption. If I hit spacebar to page down, we see some standard commands. We see ENC right here. ENC, encryption, decryption, and encoding. So a lot of these times when these man pages are huge and they have like subcommands and subsections, you can actually enter those subsections by doing TAC and then the name of the subcommand. So this is how we can look at only the manual page information related to OpenSSL encryption. So here we go. The symmetric cipher commands allow data to be encrypted or decrypted using various blocks and stream ciphers using keys based on passwords or explicitly provided. Basics for encoding or decoding can also be performed either by itself or in addition to the encryption or decryption. Okay, so let's only look at the commands, the flags that we really are interested in. What is this TAC D? So I can do a search by typing / and TAC D and hit N to go to the next one. We see TAC D is to decrypt the input data. Okay, so we're telling it use decryption mode, and TAC K and some type of password. The password to derive the key from. Cool. So we have a bit of understanding of what the script is doing, and I know we need to run decrypt.sh and we need to give it some type of file name. But which file do we give it? I believe what we need to do is look at the contents of checksum. Let's see if we can do this. grep tac L, specify our checksum on files /star. Okay, let's do cat files /star and then grep our checksum. Oh, maybe we don't want the contents. Maybe we want to take the SHA-256 actual encryption, right, of everything in files. There we go. I think that's exactly what we want. Okay, so let's hit up arrow and let's actually just grep out our checksum. Can I just do this? Cat checksum.txt. There we go. So I ran SHA-256 sum on all the files in that subdirectory, and then I just did grep with the contents of checksum.txt, and we see that we do have a hit, we do have a match, in this file here, 451 FD69B. So I should be able to just run decrypt.sh on that, and that should work. Error. That's not a valid file. What? Yes, it is. Okay. So it is a valid file. It's telling us it isn't. If I cat it out, we do see there is some junk in here. We see salted underscore underscore and then whatever this garbage means. So it is a valid file. I'm not sure why it's crying like that. Let's try going to the challenge server. Let's grab this, slam it in here. Yes, I want to connect, and we need the password that it gives us. Let's go to the actual server. Okay, ls. So everything looks the same. We still have the checksum. So let's do the same command, SHA-256 sum, everything on files. Okay, that works as expected. Now let's grep out the contents of our checksum.txt. Now let's do decrypt.sh on this. There we go. So I'm not sure if there was something wrong with my local host, with my environment. For whatever reason, it works fine on this challenge server, but it was not working in my bash shell. So let's do one more. I think this is a good video. I think we're making some good progress. Can you see me? How about some hide and seek? Download this file here. So let's right click and copy, and let's go to a new folder. This is optional, but I like to keep my notes a little bit organized in their own files, in their own folders. So can you see? Now let's move into there. Let's download the challenge file. Oops. Right click, copy link. And I just like using wget. I added that little tilde. I didn't need that. Okay, the zip file is here. So now we can unzip it. Interesting. Unknown reality. File. What's going on? Remove that zip. We don't need it. File. So it is a JPEG this time. Okay. Can we just open that up with Eye of Gnome? So we do see it is just a picture. Nothing too interesting. Let's run strings on it. Ooh, that looks like junk. Let's pipe that into less, just so all the output isn't flooding us like that. So we do see some metadata, right? If I zoom in a little bit, we do see some information. We do see begin with an ID. Perhaps that's some type of base 64 value that we need to decode. We see attribute URL with the resource equals this. So this is base 64 encoded data. So let's actually see if we can decode this. Base 64 decode. Oops. Tech D. Slam in that. Hit Control D to exit. And just like that, it prints out the flag. pwntools metadata hidden. So that wasn't too bad. So let's look at an alternative way we could have solved that. I just like using strings. I think it's nifty. It's a quick tool just to peek at some of the ASCII readable stuff that's in there. But since this is a file, or an image file rather, a JPEG or a PNG, we can just use EXIF tool, and that will automatically parse out some of that information in an easier to read format. So we get the file name. We already knew that. We get the file size, when it was created, what kind of file it is. It's a JPEG, the resolution, and right here, the attribute URL, we still get the base 64 encoded data. So let's see if we can be nifty and neat and make some type of one-liner to like parse out and grep the flag. So if I do EXIF tool and I grep equal, yeah, so that's how I get just the base 64 data, but I also get the attribute URL. So let's pipe this into cut, which is a great tool to kind of just parse out a line of text, specify the second field. So the delimiter will be this colon, and the first field is everything in front of it. The second field will be everything after it. So we hit enter, and we do get our base64 encoded data, but there is a space right there. So if I try to throw that into base64 to code, let's see what happens. Invalid input. If I do attack I to ignore junk, there we go. So if you're not familiar with base64, D for decode, and attack I can ignore garbage. So when decoding, ignore non-alphabet characters, so like spaces. So that's cool. We could have done another cut on spaces and just get rid of that, but attack I also does the trick. So that's a cool way just to practice different Linux commands, different bash syntax and bash commands. So we did exif tool, grep, cut, and base64. So perfect. That's not too bad, not too shabby whatsoever. I think that's where we'll call it. I think that's where we'll wrap it up. I don't want this video to be too long. I know my Heap Overflow video before was nearly an hour, so hopefully you guys got some education out of that. If you guys like the shirts, if you like the merchandise, it is very comfortable. You can look very suave, very savvy and whatnot when you're wearing this. So if you are interested, please look in the link in the description down below to help out the channel and look nice while you're hacking. There's been some issues with the YouTube merch shelf, so the stuff isn't popping up automatically. I am taking troubleshooting steps to get that resolved. But in the meantime, if you do want to support the channel, if you do like these shirts and how they look, they are very comfortable. So that's an option. No pressure to buy, obviously. So let me know how you guys solve these challenges in the comments down below if you want to see more forensics challenges like this in the future. And now, as always, take it easy and see you guys in the next video.